Hey you guys, I kind of gotta hurry because my battery's dying. So, we are trying to solve this system here, right? So where we left off in our two-dimensional problem with dealing with flux colliding, we saw that our masses here all canceled in our expression we calculated, and so now here I just wrote that simplified. All right, so we said our two unknowns are our final velocity of the object 1, or that speed I should say, and this angle theta, or phi. Man, I need to get to bed. All right, so we're solving for those variables, so how can we do that? So there's many ways you can do it, but the method I'm going to use is, first thing I'm going to do is make a tangent. How can I make a tangent? Well, we know tangent is sine divided by cosine. So before I even get to that, actually, I'm going to isolate. I see my two unknowns are in this one term, so I'm just going to rearrange isolating these unknowns on one side. So you have initial velocity of object 1 in the x, minus our final velocity of object 2 times the cosine of theta is equal to our final velocity of object 1 times the cosine of phi. And then similarly, we have this expression. All right, so now our unknowns are just in this term here. So I see I have a sine and a cosine going on, and I know sine divided by, or is it cosine divided by sine? Oh, now I'm double guessing myself. Can't even remember trigonometry right now. Let's see, so tangent is sine divided by cosine. All right, so if I want to do sine divided by cosine, I'm going to take this term here, or this expression, and divide it by this expression. All right, so I'm basically taking equation 2 here and dividing it by equation 1. So 2 divided by 1. That gives us, so we have initial velocity 2 in the y, minus our final velocity of 2 sine theta divided by initial velocity of 1 in the x minus our final velocity of 2 cosine theta is equal to, this divided by this gives us 1, right? And then we're going to have sine of phi divided by cosine of phi, which is just tangent of phi. Why did I do that? Because now I can just take the inverse tangent of this function here, and that gives me my angle. Right, so if I do tangent inverse of this function here, I'm not going to rewrite that. I'm not going to plug in numbers. But if I do plug in numbers, let me see, where's my work from earlier today? When I did that, I got an angle of negative 7.29 degrees. Hopefully you get that too. Hopefully I didn't make a calculator mistake. Totally possible. All right, so I found that my momentum vector is going to be at an angle of negative 7.29 degrees. So that is to say that if we had our horizontal here, we have our vector pointing in with this angle here being 7.29 degrees. Right, so the negative here signifies that it's below the x-axis. All right, so now if we wanted to find what the speed is in that direction, we just need to pick one of these formulas here and plug in our new angle. All right, so, and then we plug in whatever values we had. So let's say, for instance, I wanted to plug it in, I don't know, doesn't matter. I don't even know what I did earlier. But we have all the variables we want, say for plugging in line number 1 here. We have this variable, we have that variable. Don't forget to, nope, I don't want to mention that there. That's in the y direction. So this here is 1 meters per second. This here is 0.8 meters per second. This is the cosine of 30 degrees, which my memory serves me right is 1/2. We don't know this variable, and this is the cosine of phi, so this is a cosine of negative 7.29 degrees, right? So when you plug in phi, plug in the negative sign here, right? Don't forget to do that. So you plug that in, we'll actually rearrange first, then plug that in. I got a final speed for puck 1 to be 0.31 meter per second. Like I mentioned, this is assuming that I didn't make an algebra mistake or didn't put a mistake in plugging into the calculator earlier today. So, but that is to say that our puck 1, so puck 2, is going off in this direction, an angle of 30 degrees here. Puck 1 is going off at a shallower angle, this angle here being 7.29 as I drew just above here. Don't know why I'm redrawing it, but it's happening. At a speed of 0.31 meters per second. Let me just double check the problem to make sure that I solve for what I wanted to solve for. What is the velocity and direction of puck 1 after the collision? That's the velocity, that's direction. Great. Sorry, not the velocity. That is the velocity, but it's the speed and direction of puck 1. As to the second part of the problem, how does the final kinetic energy compare to the initial kinetic energy? I'm not going to do that solution, but you should do it. All right, thank you guys.